Hi everyone. In this video, we'll go through topic related to transpose of a matrix and we'll go through few examples related to transpose.
What is a transpose of a matrix? A matrix obtained after interchanging rows and columns is called the transpose. It is denoted this way as A dash or A to the power T, right? So, like this, let's take an example. If A is equal to, say, this is the matrix, then you interchange the rows. The rows will become columns and columns will become rows. That is, let's interchange. We have one row here. First row is 2, 3, minus 1. We will make it as column 2, 3, minus 1. Then we have second row, which is 1, 4, 5. We'll write it as a column 1, 4, 5. So when we interchange the rows in the form of columns, then it becomes a transpose of the matrix. You can write either A dash or A to the power T. The order also will get swapped. So here the order is 2 rows and 3 columns, 2 by 3. Here the order will become 3 rows and 2 columns, 3 by 2. So the order is swapped. Properties of transpose of matrices. So if you do a double transpose on a matrix, then it's going to be the original matrix itself. That is, you first take a transpose of A and then again take a transpose on it 2 times. So you're going to get the original matrix. And the next property is, assume that K is a scalar, that is some constant number. When you multiply this number with a matrix and then finally take a transpose, it is same as taking the transpose of matrix and then multiplying it with the constant. Similarly, if you have two matrices A and B, you add them and then finally take a transpose. This will be same as taking transposes of matrix A and matrix B and then finally adding them. And then same thing with respect to multiplication. So if you multiply matrix A and B and take the transpose, it is same as taking the transpose of B multiplying with transpose of matrix A. We can prove each of this with suitable examples. Let's take this example, right, where we'll have to prove that A plus B, the transpose of A plus B is same as A transpose plus B transpose, right? Let's solve this. So we'll have to add these two matrices first. So A plus B would be minus 1 minus 4, which is minus 5, 2 plus 1 3, 5 plus 3 8, 5 plus 1 6, 7 plus 2 9, 9 plus 0 9, minus 2 plus 1 is minus 1, 1 plus 3 is 4 and 1 plus 1 is 2. Now let's take the transpose of this, right? Let's take the transpose of this. If you take transpose of this, what we are going to get? Just interchange. Let's take the first row and represent it as a column. Minus 5, 3, 8. I'll put it as a column. Minus 5, 3, 8. And second row, 6, 9, 9. I'll make it as a column. 6, 9, 9. Third row, minus 1, 4, 2. We'll put it as minus 1, 4, 2. So this becomes the transpose of A plus B. Now let's call this as one expression or one equation, right? Now let's call this as one expression. Now let's find transpose of A, transpose of B, and then add them. We'll have to prove that the resultant matrix that you get here is same as this one. So let's take A transpose, right? What is A transpose? This is A matrix. So transpose of this is, take the row, first row, minus 1, 2, 3. Minus 1, 2, 3. I will write it as a column. Second row, 5, 7, 9. 5, 7, 9. I'm writing it as a column. Minus 2, 1, 1. This is the third row. I'll write it as third column. So now I've got the transpose of A. Similarly, let's get the transpose of matrix B. Matrix B, first row is minus 4, 1, 5. I'll write it as minus 4, 1, 5 in column. Let's take the second row, 1, 2, 0. 1, 2, 0 as column. Third row, 1, 3, 1. We'll write the third row as third column. 1, 3, 1. So this is the transpose of matrix B. Now let's add both of these. So when you add both of these transposed matrix, we're going to get, add this, minus 5, 5 plus 1 is 6, minus 1, 2 plus 1 is 3, 7 plus 2 is 9, 3 plus 1 is 4, 3 plus 5 is 8, 9 plus 0 is 9, 1 plus 1 is 2. So let's call this as expression 2. Now if you look at this expression 1 and expression 2, both the matrices are same, correct? Both the matrices, all the row elements and all the column elements are same. Therefore, A plus B, the old transpose is equal to A transpose plus B transpose. Similarly, we can prove the second problem also. A minus B, the old transpose, is equal to A transpose minus B transpose. Now let's take another example. If matrix A is having trigonometric elements, cos alpha, sin alpha, then we need to verify that A transpose into A is I. I is nothing but the identity matrix. So if you multiply the matrix with its transpose, then we are going to get identity matrix. So what we will have to do is, this is matrix A, we will get the A transpose, right? So take cos alpha sin alpha, which is the row element here, put it as column element, cos alpha sin alpha. Then second row, minus sin alpha cos alpha, put it as column element, minus sin alpha cos alpha. Now multiply this matrix and the transpose matrix. When you multiply both, you are going to get cos square alpha and sin square alpha. Then here what's going to happen is, second element, it's going to get cancelled. You're going to get cos alpha sin alpha and cos alpha minus sin alpha. So this is going to get cancelled. Here also, minus sin alpha into cos alpha plus cos alpha into sin alpha. This is going to get cancelled. And then here you're left with sin square alpha and cos square alpha. Now based on trigonometric formulas, sin square alpha plus cos square alpha is equal to 1. That is cos square theta plus sin square theta is 1. So you substitute 1 here, right? So you will get identity matrix. For identity matrix, diagonal elements are 1s and the remaining elements are 0s. Let's take another example where we have to show that if you take a double transpose of a matrix, you will get the matrix itself. So we have matrix A here. Let's take transposed twice. So transpose of this is going to be, row is 2, 4. Row is 2, 4. First row is 2, 4. I'll put it as column. Second row is 3 minus 1. I'll put it as a second column. Third row is 4, 0. I'll put it as third column. So I want to change the rows and columns. So I get the transpose of matrix A. Now let me find the transpose again, right? Transpose of this. Transpose of this would be, I can either write A to the power T or A dash. Doesn't matter, anything. So now I'll take a transpose again. So I have the row as 2, 3, 4. I'll write it as column 2, 3, 4. Then I'll take the second row, 4 minus 1, 0. I'll write it as column 4 minus 1, 0. So now let's observe this matrix and the original matrix. Both are same, right? This matrix and this matrix is same. Hence we can conclude that double transpose is nothing but the matrix itself. So let's take another example where a matrix is given, and if you multiply this matrix with a constant or a scalar, then the property states that K into A and the old transpose is equal to K into A transpose, right? So what we'll have to do is, first we'll take matrix A and assume that there is some scalar K, multiply the scalar value with the matrix, right? And then get the transpose of it. So it's going to be, when you multiply, what you're going to get, K into 1, K minus 2K, 3K. This is going to be a simple multiplication. 4K, 5 into K minus 3 into K. Simple multiplication, scalar multiplication. Now we'll take the transpose of this, right? The transpose of this is, let's take the first row, K minus 2K, 3K. So it's going to be column K minus 2K, 3K. In second row, 4K, 5K as column, 4K, 5K and minus 3K as column. So what we have got? We have got K into A, the old transpose. Now let's call this as expression 1. So we have got this, we have obtained this. Now we'll have to obtain this, right? So that is nothing but K into A transpose. K into, let's take the transpose of A. This is matrix A. This is matrix A. Transpose of this is, let's take the row 1 minus 2, 3. So it's going to be 1 minus 2, 3. I'm going to write it as column instead of rows. Then 4, 5 minus 3. 4, 5 minus 3. 4, 5 minus 3 as column. So I've taken the transpose of matrix A. Now I'll multiply with the scalar. What will I get? K into 1. K into 4 is 4K minus 2K, 5K, 3K and minus 3K. So this is what I get. Let's call this as matrix 2 or expression 2. Now you look at both these matrices, right? K, 4K, it is same. That is, KA, the old transpose, is same as K into A transpose. Hence, it's concluded that K into A, the old transpose, is K into A transpose.
With this, we have come to the end of this particular topic. Thanks for watching. Hope this video was useful.